this lesson, we will be looking at the intersection or the union of two sets. First, let's review a more formal way of expressing the solutions to inequalities. We refer to this as interval notation. The left end bracket or parenthesis will go with the lower bound, and the right end bracket or parenthesis will go with the upper bound. The lower bound is the smallest number in the solution set, and the upper bound is the largest number. The notation will be used to represent all real numbers between that lower bound and that upper bound. For practice, let's say our solution is the inequality x greater than 3. Until you are fully comfortable with interval notation, as a middle step, I represent the solution on the number line. Understand x greater than 3 is all real numbers to the right of 3, not including 3. A left-hand parenthesis is above the 3, the lower bound, and an arrow is drawn to the right representing the solution set going on forever in the positive infinity direction. Infinity is always enclosed with parentheses. Moving on to our second example, x less than or equal to -1. Again, I represent this on the number line as a stepping stone to the interval notation. A bracket is used on the upper bound since -1 is included. The solution set goes on forever now in the negative direction. Transfer this information to your interval notation. If your solution set is all real numbers, the entire number line would be shaded in. Interval notation is -infinity to positive infinity. And again, infinity is enclosed always with parentheses. This is read as all real numbers between -3 and 5, including 5. We're not including 3, so therefore there is a parenthesis at the left end. The 5 is included, so there's a bracket at the right end. Let's begin our discussion of intersection by working with sets. Since we're dealing with sets, braces are used. Set A contains the numbers from 1 to 8, and set B is any even integer. The upside down U is telling us to intersect the two sets. If you're asked to intersect sets, you are looking for those numbers that are in both sets. The even numbers that are in set A are 2, 4, 6, and 8. This time, we're asked to combine two sets. Union is represented by the upright U and is asking us to create a new set with elements that are in either of the two sets. Sets C and D are combined. If a number is in both, only state the number just once and in ascending order. Here the sets are combined with the numbers in ascending order. Now we're moving on to a compound inequality joined by the word and. The word and is telling you to intersect these two sets. Since there are an infinite number of numbers in these two sets, we're going to use the number line to help us find those numbers that these two sets have in common. Again, to find the numbers these two inequalities have in common, draw the representation above the number line. Since we are looking for the intersection, we are looking for where these two inequalities overlap. The numbers these two inequalities have in common are all numbers between -5 and 2. Here's another compound inequality joined by the word and. Before we go on to the number line to see where these two inequalities overlap, we need to solve both of these for x. The math on isolating x is fairly easy. Make sure to flip that inequality on the second one since you are dividing by a negative. The word and is asking you to find numbers that are in both inequalities. So again, we are looking for where the two inequalities overlap. Bringing the result down to the number line, it is all numbers less than or equal to -2. Moving on to a compound inequality joined by the word or. With the word or, you are asked to find those numbers that are in either. Here the two inequalities are just simply combined. Solving the inequalities for x first, and then next addressing the union of these two sets. If the inequalities are joined by the word or, you are asked to combine the two inequalities for the final solution set. You are representing numbers that are in either of the sets. This one is referred to as a double inequality. You are done when x is isolated in the middle. What you need to do is, in isolating x, is do what you do to the middle to all three parts. So start by subtracting 6 and then divide by a -1. Now remember, when you multiply or divide by a negative, you must flip that inequality. When you state the solution set of a double inequality, it must be done with two less thans. See, this is written backwards. If you flip the inequalities, flip the 2 and -3 to get this stated correctly. We now have it stated correctly, and it says all real numbers between -3 and 2. State this in interval notation.